Okay, so the recording has started. Thank you guys for coming out. I'm sure a few more people will pop in as we go along here. We did change the time at the last second, so it might be some people might not have adjusted to that, but that is okay. All right, so today we're doing a report, so to speak, but it's more of hacking demonstrations from the CTFs that we've been attending over the past few months. We've got some skilled people here that are going to be doing the demonstrations. We've got Thomas and Megan. They've got Megan's got 2 challenges from the Sands holiday hack, and Thomas has 2 challenges from the Insomni'hack CTF. Another thing to note is that over the reading break, we'll do just kind of a drop-in Q&A hack together kind of thing. Kind of an open lab for hacking where, if you want to talk about tools and stuff like that, we totally can, or just talk about anything hacking related. Nothing formal or like what we normally do, just because it's reading break. So yeah. Oh, I guess I said that slide, but we've been hacking. We want to report these challenges to you guys, and it's also a case for people to see what it's like. But in this case, I don't think there's anyone here that isn't familiar with CTFs or hacking, so I guess it's still just show and tell time. Okay, so the agenda for today's meeting, the first challenge will be ExPiltration. Thomas will be showing us that one. It's from the Insomni'hack, and it's the forensics category, MISC forensics. And then the second challenge is slot machine investigation. Megan will show us that one. It's from SANS. It's web app exploitation. The third one is Herald. Thomas will show us that. Insomni'hack, mobile reversing. And so we'll get a taste of that too. And then customer complaint analysis. Megan will show us that one. It's from SANS, and it's web traffic analysis. So in a moment here, Thomas will take over. So as soon as he starts sharing his screen, he can just take the ball and roll with it.
All right. Thank you. And hopefully this will work. All right, so I kind of targeted this more towards expecting a lot more beginners here, but this works too, I guess.
We
Um,
tape these
yeah,
so
yeah, yeah,
people can
yeah,
watch them after.
yeah. So, anyways, just for those who may have not actually been in a CTF before, this is basically what you'll see when you start, when the challenges open up. You'll basically end up with a sort of a Jeopardy board of sorts. They call it a Jeopardy board. You got these different categories like reversing, web, pwn, mobile, forensics, and so on. So we'll open up this ExPiltration challenge, and this is our challenge description. This tells us where we need to start. So they come up with a story for all these different challenges. In this case, the story is that uh, their network has been compromised, and there's some kind of air gap device that attackers have gotten access to, and they've exfiltrated some data. And that data is what we need to figure out. We need to know what they got off of the device. And they also have 24/7 video surveillance, supposedly, so uh, that's always handy, I guess. And they give us the zip file. So we download that, and we're given the zip file here. It has 2 entries. So we got this surveillance footage, like they kind of mentioned. We also have this storage directory here, and I'll get to that after. So this being just a zip file, I just extracted it, and yeah, so we got this and this. Ignore the other stuff for now. First thing we did, Megan did actually, I can't take the credit for that, is took a look at this footage here. So we open it up, we got this Raspberry Pi sitting in the middle, it seems, or some kind of SBC in any case, It's just got power, like they mentioned. It's air-gapped, not connected to anything, and it's sitting on top of a network switch for whatever reason. The date is, March. I guess they kind of set it in the future. And that's all of interest, really. If we play it, though, the only thing we see is this, like, network activity in the background. And that's not really important. We can skip ahead a few minutes, and nothing interesting happens for the first few minutes. But right around 7 minutes in, you'll notice something on the Raspberry Pi. These two lights down here start blinking, and that's basically the entire video. Is just these two lights blinking and the timer going, and that's it. It ends shortly before the end of the video itself, and then it just goes back to just a red light. So, um, we didn't really find much more in here. Megan looked for like missing time if they cut the footage somewhere, but we didn't really find any of that. Um, but Aaron and Aaron was also working on this, looking at this together with us, and we kind of noticed like a bit of a pattern with these lights. It seems like this green light's kind of um, signaling something, like it's Morse code almost or something like that. So we found that interesting, but I mean, we're not gonna like sit here and try to decode Morse code off of this. So I decided I'll put this aside and I'll go look at that storage directory. So if we open this up, we see a pretty typical Linux root directory. You got your bin, dev, etc, home, all that kind of usual stuff. Although oddly enough, they seem to have like stripped out a lot of the normal binaries you'd see in here. So like bin, this would usually be filled up with files. There's nothing here. So those are usually system files that don't really carry any information that we care about. So I think they just got rid of that to reduce the download size of the file we need to get. And at this point, I was actually working my terminal, so I didn't really see this, but the first thing I did was look for any recently modified files, the most recently modified file, because usually that'll point to what you need to look into first, because if the rest of the files will all be system files that have been modified long ago, and you care about basically the most recent activity. Unfortunately, it appears that like every single file is just set to the same timestamp, as you can see here. So that didn't really yield any useful information. And if you're wondering why some of these are different, that's because these are inside here are link files, and they set the modified time to whenever you extract the zip file. So these are actually fake timestamps. But what I did find when I was looking for the most recently modified file is this user folder showed up at the end, and I kind of noticed it seemed a little odd. There's one item in here, and there's one item in here, and we have this system update.py, which is kind of weird because everything else, there should be, thousands of other files in here. And this is I believe this is built into Raspbian, which you would usually find on like a Raspberry Pi like this. So in theory, this is a file that should exist, but it's weird that they left this in and nothing else. So I went and I opened it up. And I might zoom in a bit so you guys can see better. Hopefully that's readable. And yeah, so in theory, this is an update script. This does not look like an update script. You got mentions of secret files, ExPiltration, so on. It's pretty obvious right off the bat that this is definitely an attacker controlled, like a script that the attacker made, and not actually an update script of any kind. So if we come down to, there's just function definitions, come down to the main function here. It initializes LEDs and then restores them after the fact at the end. And the main kind of logic is stored in this function here. So all of this really just looks for key files and CRT files. So any file that ends with key or CRT in the file name, and the path it's looking through, the directories it's looking through, is under this /home. So it's going to look at everything under /home and find any key or CRT file and make a list of them. And then it's going to go through that list and it's going to supposedly, exfiltrate that file. The way it does that is by reading it into memory and then calling exfiltrate on that data that it read. So if we look at exfiltrate, the first thing it does is convert all of that data that it read into a bit stream. At first, when I was looking at this, I actually kind of thought this was some kind of weird encoding, and I had to like decode all of this. But it turns out all it's really doing here is taking the raw bits from the text and kind of expanding it, so it turns it into literal ones and zeros in a string. That's all it's doing there. So that's not very interesting. What is interesting is this loop right here. So it goes over every 1 and 0 in the bit stream, and if it's a 0, it sets this LED, this LED 0, whatever that is, to a 0 brightness, so it turns that LED off. And then if it's a 1, if it's not a 0, right, it turns that LED on, whatever this LED 0 is. Then it waits a
It
bit.
is the pin number for the board.
Yeah. Yes. Thank you, Megan. That is more accurate, yes. So then it waits a bit longer, and it turns on LED 1. Then it waits a bit longer, turns that LED back off, waits a bit longer again, and then it restarts the process. So it just does this for every single bit in the file. So that pretty much points directly to these two LEDs somehow are likely what we need to look at, what we need to decode, and that should, in theory, give us the flag somehow, or lead us one step closer to the flag at least. Now, when we looked at these two LEDs, we looked at how they acted. It seemed to us, we kind of guessed that this red would be the clock signal, the LED 1. So if I can put this up at the side, this LED 1, it just turns on and off and on and off, kind of repetitively. And if you look at these side by side, it's kind of obvious that this one's acting towards some kind of pattern, whereas this one's just turning on and off consistently. But if we want to be sure, we can actually skip to the end of the video. So what it does at the very end of its script, once these blinking lights are done and it's turned off, you'll notice the red light's back on consistently and the green light's just off. Now, what it does to restore the previous state of the LEDs is it sets these two triggers. So basically this is automatic, like it's controlled by the Linux kernel itself, I believe, where based on certain activity or conditions, it'll turn the LEDs on and off automatically, like at a system level. So it sets the default on trigger to LED 1, and it sets MMC 0 to LED 0. So MMC is like flash storage, basically the storage of the Raspberry Pi, and that sets it to that'll be set to LED 0. So whatever LED 0 is, it'll basically turn on only on disk activity, whereas LED 1 will be on consistently. And so that matches our expectations, right? We expect LED 0 is probably the green one, and LED 1, which is the kind of clock, to be red. So that at this point we pretty much know at a broad level what we need to do. We just need to do it. We need to decode the green LED signal back into the bit stream that the attackers were able to exfiltrate. Now, I am told that there are scripts online to kind of automatically take a video like this, look at these two LEDs, and decode a bit stream from them. I was not able to find like a good script to do that, so I just figured I would make my own. So on that note, let's look at what I came up with. And this here is the source code. So I'm using both Pillow and PyAV. Pillow, you're probably all familiar with, image manipulation library. And I'm using PyAV, which is like it's basically a wrapper around FFmpeg, if you're familiar with it, which is, I saw other people using OpenCV. It's more or less an alternative to that. So, we open up the video file, and we iterate over every single frame in the video file. For every single frame, we turn it into a pillow image, and then we want to get a specific hard-coded pixel because I'm lazy and I don't want to make it configurable. And we get the red channel. That's what this here does. We just want the red value of the red LED. We want to know what its red brightness is, essentially. Now, what this mess here does is just keeps track of whether the red LED is on or off. So the reason that we actually need two LEDs, we can't just go off of the green one itself, is because we don't know what the precise timings are. I mean, we can look at the system update source code, and it says, 50 milliseconds is the delay, so it should be every 150 milliseconds you should, in theory, be able to read the green LED. The problem with that is that these timings aren't precise, they're not very accurate, and over the length of the video for like 50 minutes, they're going to drift further and further away, and eventually what you're decoding is going to turn into rubbish. It's not going to make any sense. So that's why we need the red LED as well. It acts as a clock signal. It'll turn on and off in sync with the green LED. And that's essentially it for that. Then whenever the red LED turns on, we read what the green LED is. We check if it's on or off using just thresholds. All of this uses just hard-coded thresholds I put up here. This is like the 70th iteration of the script or something. I lost count. I just kind of played around with these values until I got a good bit stream out that actually made sense. Then at the end, we just we take that list of ones and zeros and turn it into an actual file that we can open up after. Now, the the important part of using this script is that I actually, before I ran the script on this video file, I used FFmpeg to just cut out a 40 by 20 pixel region right around these LEDs, and I can hopefully show you what that looks like. Basically just looks like that, zoomed in. And that way, this script has way less to process. This script can run in 20 seconds. I saw some other people who didn't crop their video, and it took more on the order of 2 hours to run. So that's kind of an important step when you're doing stuff like this. Now at that point, I got this decoded bit stream out, and it's just a very long list of ones and zeros. Not very readable. But we can copy paste this into CyberChef, which for some reason I do not have open. 1 minute. CyberChef. This is a very handy tool for all kinds of data manipulation and decoding, especially in CTFs where you like to be able to kind of iterate very quickly. We're going to go binary from binary. And here's what we see decoded. We see the start of an RSA private key, supposedly, but it kind of turns into garbage right around here. Now the reason for that is we're actually missing 3 bits. 3 bits I could not get to actually get my script to detect it. I tried to do that. It didn't work. Now, when I was actually doing this challenge, I thought that I would need to get these bits exactly perfect, Turns out you don't have to do that. If you throw a bit in there, you can see the base64 contents of this RSA private key, and you can decode this, try to see what's inside, but it's really just a randomly generated private key, unfortunately. So then I figured, well, I guess we need to look at the certificate. There's 2 more bits here. CyberChef helpfully tells you what input corresponds to what output, and so on. That is not correct. Sometimes it's not very accurate, apparently. My bad. Probably should have done this before the fact. This is a very condensed version of what I actually did in the challenge, though. This should be good enough, though. So I actually spent way more time trying to get this all perfect, but it turns out this is literally just an OpenSSL readable certificate when it's actually properly decoded. We don't actually need to worry about that. If we go and put this, just the majority of this base64 back into CyberChef, we will see, well, we'll see gibberish because it's not padded correctly, but there we go. We padded correctly so that it base64 decodes correctly, and there's our flag. So basically, to recognize a flag like that in the CTF itself, it says default flag format. You got like INS, open bracket, and then some kind of text inside. So that tells you what you need to look for a flag to submit to prove you've solved the challenge. So then you copy paste that, send to them, and that's pretty much the challenge.
Good job. That I want to let you know you did really good with that demonstration. It was honestly pretty I would say like exciting from beginning to end there. So thank you for sharing that, Thomas.
Right, well,
Does anyone have any?
seconds.
Sorry, I was just gonna open it up for questions.
Yeah. If anyone has any questions or any comments or anything, otherwise, I'll give it maybe 20 seconds and then Megan can take over.
Yeah, if you got questions, drop them in the chat. We'll address them. If not, Megan, take it away.
Okay. His are more exciting than mine, but I did try and purposely pick challenges that were different kinds of challenges than he did, just so that we get a more rounded out showing of what kind of challenges there are. Unfortunately, I don't have any from the recent Capture the Flags, but I do have the ones from the Sans Holiday Challenge that we had done. So I'm going to show you kind of that. Okay. So I don't know how many people actually did Sans or have looked at it. So this is kind of what their interface kind of looks like, and you go around to different rooms and things like that. These are the challenges I actually did. I didn't do 4 of them, but I did the rest. And then there's also other challenges within that give you hints for the challenge for the challenges under the objectives section. So the challenge I'm going to show you right now is slot machine investigation. So it says test the security of Jack Frost slot machine. What does Jack Frost casino security threaten to do when your coin total exceeds 1,000? So you submit the string, and then there is clues under the hint section if you finish the things. So if we go here, you can see that I'm just looking for the ones about slot machines. So one says, Web application testers can use tools like Burp Suite or even the right browser with Firefox's edit and resend feature. And then the other one is, it seems they're susceptible for parameter tampering. So for those who don't know what parameter tampering is, it's, here, I'll actually just click this and we'll be able to see. So like things that you can change are, you're looking for like combo boxes or check boxes, things that you can change. Values like costs, or in this case, since we have a slot machine, it will probably be, you're looking for things like buy-ins, the cash outs, things like that you might be able to change. So when I open, so you go and you can open the slot machine here. It plays music, so I've already opened it. And anyone who, I think everyone can access this link, so I can post it if anyone wants to follow along that way. But yeah, it plays music, so I had already opened it. So then we're here. I could do it in Burp Suite. I actually tend to use Firefox. I don't know why. I like Firefox. Can cooperate? No. Yeah. Why is it being done? I'm having technical problems in my computer for some reason. Okay, I'll be right back. Sorry. Give me 1 second. It won't let me open the developer tools, and I don't know why. I normally can just press my mouse button and it pops up, and that's not a thing, and I don't know how to get it elsewhere. I'm just looking.
F12 usually.
I have a MacBook. There we go. Web developer tools. There we go. We'll start with that. There we go. I found them. We're good. All right. So going back to here. I don't know what's up with it. Sorry about that, guys. So when we go into here, with web app challenges, you should always be looking at this, but because you know it has something to do with parameter tampering, the best place to start is in the network tab. So to figure out what the payout is, I'm just gonna like put up the bet, put up the slot, and then I'm gonna hit spin. Oh, yeah, fine. So then if you go down to the bottom here, you see that the post from the spin. So that's what you want to look for, is the post. And we're going to look through what's in here and see if there's anything we can edit or change. So you can see that there's cookies and stuff like that. So Firefox has a edit and resend feature that allows you to do edit. It's like Burp Suite, where it allows you to edit a thing and then resend it back so that you can see the new request if there's any changes. So when we go into it this way, in the request body, you can see that there's a bet amount here, the number line, and the CPL. So with challenges like this, where you have to, you're trying to reach $1,000, but you don't know when you're going to win or lose, the best way to do it would be to create a negative value. Now, if you change the bet amount to a negative value, it tells you that the bet amount has to be above 0. So we're actually going to change the line amount to a negative value, because what this will do is it's the bet amount times the line amount. So if this is a negative value, then every time we lose, we're actually going to win money. So, and then once that is edited, we hit send. You go back into the new one, you can see your response. You have your credit. And this is actually, because I have the values so high, it automatically gets the correct message for me. If you use lower values because you're unsure, it might take a few times. But since our credits are now above 1,000, it tells me the message that the challenge is looking for. These challenges were hard when I did them. They do not seem so hard anymore, but I have learned a lot since then. And that's how that challenge works. It's not very as in-depth as Thomas's. And that's what it. Thomas, do you want to do your other one, or do you want me to do the other one I have?
Not sure if you can hear me, but you can go for the other one.
Okay. It is also not very exciting, but that's okay. All right, so the other one that I have here is another one from the Scientology challenge. There was some harder ones, but I didn't know who would be here, and I didn't want to make them too hard. This one's shell primer. This is the one I was going to originally show. So this was literally writing in. There was like little tutorials, and then it taught you kind of how to write in assembly to run actual programs, and then it put stuff into values, and there was hints that you could get and things like that. It was actually a really cool challenge. These are still available for anyone who does want to try them. They're still up. You just can't compete in the actual challenge part. So the other one here I'm going to do is customer complaint analysis, which is just a PCAP file. So they're looking for the trolls who complained about a human that had submitted requests. So I have the PCAP file here open. So the first thing I kind of did was look at what kind of was here to see what might be. And you see the guest complaint here. So then I went to go look at it. Kind of see that this isn't really what you're looking for. And then we go down farther. And you see a post with guest feedback. And here you see a name with all the information about people complaining. So what you're probably going to want to do is look for anything with post in it. I don't remember. It apparently messes up. Okay, so I just did it this way where I just went through to find anything. So we know there was a human involved. There is a way to filter it out so that it's only post that shows. I don't recall how to do that at this very point in time. Okay, sorry.
It's in the chat.
It's in the chat. Thank you. I'll make my life easier. I'm way too tired to do this. Okay, so making my life easier, because, yeah. So the command is http://request.method equals post. So now we have only 16 different posts left. So if we look through these, it's a lot better than it was before. You can see eventually we come to one with an actual full name. Muffy von Duchess Sebastian. She says she's in room 1024, and she actually has a real complaint saying that the people here are insulting. So this is probably the human here. Then when we go back through here, you look which her people were complaining about the lady in 1020 room 1024. So you can see that it's Yak, Flood, and Hag. They all complained about someone in room 1024, which is the room that the lady was in. So that's kind of how this one worked for web app exploitation, or for not web, for log analysis, which is this is log analysis and web traffic analysis. I use the string function quite a bit to look for stuff. Using this makes it a lot easier though, but I do use that. You can't use the TCP or the HTTP traffic analysis for these ones because it doesn't show the feedback since it's a post thing. And yeah, that's what it. I'm very bad at presenting. I'm very sorry, guys.
No, you definitely did really good. You might think,
Like I said,
I was gonna say, you might think that you did bad, but you actually did really good. It's not as easy to present as it seems. Definitely drop some
and
clap emojis in the chat so that everyone knows they did good.
yeah, like I said, mine were a lot simpler than Thomas's, but his were good ones to pick. I definitely liked the ones that he did. And like we were looking at the one that he did first for a while before I was like, I'm gonna go move on to something else because he had the idea to write the script and everything like that. So
Yeah, I kind of just ran away with it and spent the next like 4 hours just on that. It took
I think
forever.
Andrew suggested that we cut out the square of the lights, I
Yeah,
believe.
yeah,
Yeah.
yeah. Um, but anyways, yeah, I'll be right back. I just need to switch back to the desktop app because it likes to kick me out whenever I view other people's streams, apparently. So anyways.
Yeah, no worries. Yeah, it's good. I think web apps a really important one to demo, so I think that those were good choices, Megan. And also, I like what you said about how they felt much harder back when you were doing them, but now that you look at them, they're so much easier. That's always how it is. It's it's so much easier to look back and be like, that wasn't so hard. But back then it was hard.
Well, back
Absolutely.
then, this was like 2 months ago, and I had way less experience with capture the flag events than I do now.
Right.
And I've seen way more challenges and way more write-ups and way more different ideas and worked with different people that like more people who gave us more tools than I knew 2 months ago, because it was probably about 2 months ago when I did these.
It's a lot of growth in just 2 months. It's pretty awesome.
Even just from like the start to the like reviewing a challenge right after you did it, things seem way easier in hindsight. So
Totally
You're like,
agree.
why did I miss that?
exactly. Yeah. All right. Hopefully, I can share my screen. All right. So same thing as before. Same idea. New challenge. So in this case, we are given this APK file. We'll get right to that. The challenge description wants us to find a password, the password to this messaging app, so that presumably we can extract the flag from the messages inside the app or something like that. So we download this APK just like before, and we get this APK here now. Considering my audience, I think I can skip some of this. Sorry about my keyboard, by the way. So yeah, we see it's a zip file, which makes sense. We expect that of an APK. And the first thing I really did was decompile it with JADX. I don't remember the exact command. I'm going to have to look it up here. Because I believe, yeah, I used a crap ton of options for it. So I used this. To be honest, I don't know what this does, but I think it's important for my computer because I'm on Linux. Aside from that, you probably don't need this. But deobfuscation, always nice to have, even though in this case it didn't really do anything because this thing isn't obfuscated. And then this is just telling it to decompile into a decompiled directory where we can see what the Java source code, or rather JADX's interpretation of the source code is. So if we go run JADX, we can wait a few minutes. In the meantime, I meant to do this before the demonstration, but I'll get Genymotion running in the background. And we have finished with 4 errors. As far as I can tell, these are just kind of the usual errors you kind of expect when you decompile apps. So we're given this folder. I open it up in VS Code. And yes, I trust the authors. I would not normally recommend doing this, but in this case, it should hopefully be okay. There's actually one challenge, I believe it was the warm-up challenge for this competition that actually messed with your bash RC and stuff to pretend to hack you. So anyways, first thing we look at is the Android manifest.xml. Now this will tell us basically when we start the app, what activity does it, what code does it run first, really? And we can see right here, con.herald.main activity. It basically registers as the main intent as far as I can tell. So we go look at our source code, we go com, herald, main activity.java. Now this looked a little surprising to me at first because there's not really any code here. There's just the name of the application, and it says it's extending a React activity. Now, at this point, I pretty much poked around a little bit more, but everything I can see kind of points to this being a React native app. So as a kind of traditional app would be written in Java or Kotlin, and so you would see the actual logic of the code, or sorry, of the app in the code here. You'd see what it's doing, and you'd be able to figure out how you need to exploit it or bypass authentication or whatever you need to do from that. But in this case, all this is just wrapper code around a React Native app. So I Googled a couple things and ultimately found that this index.android.bundle contains the actual React Native code, the actual code that you write when you create a React Native app. So, this took me way longer than I'm demoing here to figure out, so bear that in mind, I guess. I'm giving you the very compressed version. But if we try to figure out what kind of file this is, it is a Hermes JavaScript bytecode file, version 84. So I had no idea what this is. Hadn't heard of Hermes before, hadn't heard of JavaScript bytecode before, really, other than, like, in theory, I guess a JIT creates that. So, this is more or less what I Googled. And this is what I came to. And, this made it, yeah. I went through an entire maze of, like, figuring out what this was. I didn't know at first that it was, like, what Hermes.js was. I was trying to decode it like normal. But eventually, I found this answer right here. My friend made this tool, HBC tool, to disassemble / well, not decompile, but I guess disassemble is a heck of a lot better than a binary file I can't read. So, yeah, in theory, this project should let us take this file, which VS Code won't even show at all, and turn it into something at least somewhat readable so we can figure out what the application's actually doing. Now at this point, Genymotion, one moment, technical difficulties. Okay, never mind. Jenny Motion's back. Okay, so we start up our fake, our emulated device. And that'll take a sec. It's probably gonna fail because Jenny. Alright, make a liar out of me. Jenny Motion's deciding to behave for once. I would use Android Studio. I never seem to be able to get it working, so this is what I'm stuck with. So I'm just going to take a quick detour from this HPC tool stuff to actually show you what the behavior of the app is when we just try to run it. Handily enough, they actually compiled this with like support for every architecture, so we don't need to worry about performance running on an emulated device on a x86 device. But anyways, we see this login screen. We got this image, doesn't seem we can do anything with it. We got this login about tab. About tabs are often fun. A lot of consoles got hacked this way with web views in here and whatnot, but in this case, it's just text, nothing interesting really. All we have are these two fields and this login button. So it tells us wrong username password combination. It says it again here for some reason. And no matter what we type in, really, it just does the same thing. We can try admin. We try that. It says something different. It says attack attempt detected down here, and you are not the admin liar, which is, you know, it's a bit more interesting. You can try a couple of common passwords if you spell them correctly, but yeah, nothing really pops up. In theory, apparently one solution was to just brute force this in a very convoluted way, but that wasn't really the way I wanted to solve this, and I kind of figured it wouldn't be feasible. So it seems we need to get past this login screen somehow, and that is why we're decompiling. That's kind of the motivation for decompiling, figuring all this out in the background here. So anyways, back to HPC tool, back to this index.android.bundle file we're trying to disassemble and understand. Now, one problem with this is that this only supports 4 different versions of the bytecode, and it stops at version 76. Now, if you remember from back here, it's actually version 84 that we have. So, that was annoying. I tried to run it anyways, and it kind of just complained and gave up. Thankfully, if we go to the issues, we have somebody complaining about that back in October. And we have this wonderful person 16 days before the competition who created a very unstable, non-tested workaround proof of concept for version 84. So we go here, we download his version of HPC tool, and it doesn't even update it here, but, whoops, we go run his version, which I have downloaded here. And I explain this in more detail in my write-up, by the way, which I'll post later. I'll send the link in the chat or at the end. We can run this with poetry run HPC tool, I think. Yeah, there we go. And it tells us how to use it. Very simple. Just it's sem, and we take this HPC file and we turn it into a HASM path. And what they mean by this HPC file is explained in the examples down here. That's just the file that we have. So if we do that, we can disassemble it into some kind of human readable form so we can actually read this and understand what's going on. So we'll do that. This finishes real quick. And we are given 3 different files here. Very large files, all of which are text files. I was kind of worried to open this up in VS Code, but thankfully it doesn't crash immediately. I go and open that up. Don't open the JSON files. That will crash your VS Code instance. Learn that the hard way. But if we open this up, I'm actually going to zoom out because this is a file with about 200,000 lines. We have this kind of, actually reminds me of Smalley, which is what you would get if you use APK tool, which we'll actually be using later on a APK. It's this kind of assembly-like bytecode format. Not the most, what am I doing? Not the most readable, but it's a heck of a lot better than not seeing anything. So the first thing I actually searched for, because I am not reading all of this through, looking for things, is password, and we get 10 matches. Now the first one, this looks to be, which is common in actually even just normal Android apps, it looks to just load a bunch of strings, so that's not very interesting. Then we get URL.password, or not generally. It's kind of interesting that there's any URL stuff in here, but not really interesting. We get password rules. This doesn't seem interesting either. We get set password. That's very interesting. Maybe we can potentially change the password that's protecting this, or clear it entirely. And there's the function actually of that same name, set password. So we'll keep that in the back of our minds for later potentially. And then we get this. So this is in a function called tryAuth, and it starts by, I don't know, loading some kind of state, and then it gets a username, and it loads a constant string of admin, and then it checks if something is equal to something. It seems to check probably the username based on these register names against admin. And so this jumps like out of this code flow somewhere else. I don't know where this is. If I understood this format better, I would, but I don't really care. Basically, if the username is not admin, we can figure out that this kind of code flow gets interrupted. It goes somewhere else. So if we want to continue to where it seems to check the password, we want an admin as a username. And then it has this decoded text here. I didn't honestly follow all of this. It's kind of boring. I think I actually dropped this to work on another challenge in between. But I came back to this, and looking at this with fresh eyes, I noticed these two jumps are helpfully highlighted here. So if we kind of look at the general code flow, we do this password check stuff, and it gets to this wrong username password combination. That's actually probably hard to see. Hopefully that's a bit better. And so this is the message we remember from over here if we type in any kind of anything other than admin, really. So my best guess at this point is, okay, well, if this whatever this jumps to probably jumps around to here, and then it'll probably, set print. Sounds like it's going to display this message in some way to the user, which we see here, and then it jumps unconditionally somewhere else. Now there's another sort of block of code here where it says, well, you are not the admin, and attack attempt detected, which is what we remember from trying to log in as an admin. That matches up perfectly. And then again, it unconditionally jumps away somewhere else. And then right below this, very interestingly, it says decoded flag here. It's like it's loading some kind of flag that we need. And this is what really kind of prompted me to look at this in much more detail. It's when I noticed it's a decoded flag here. Now, I don't actually pretend to understand what any of this does aside from do something with a decoded flag. But I thought, we know how to get to this state right here. We know how to get this piece of code to run because that's what happens when we just enter anything in with admin here, right? It'll show this message and then it'll jump. And this, I'm just kind of guessing here, but this seems to be what we want, the kind of the successful execution path, what executes if the authentication succeeds, if we get the right password. So I made a bit of a wild guess. I thought, well, what if we just comment that out, comment this jump out, and we log in as admin, and we see what happens. Maybe whatever, maybe we'll get in that way. And that's pretty much what I did. I saved this file. I would usually recommend making a copy, but in this case, we don't need to worry about that. Close that and went, okay, how do I get this to run now? Well, our first step is going to be rebuilding this index.android.bundle. Just like we disassembled it, we want to reassemble it back into, why is it, oh, all right, well, make sure you're in the right directory, I guess. We're going to assemble it basically just going the exact opposite direction, doing the exact opposite of how we got the bytecode readable. And we need to generate an index.android.bundle. And we'll do that. That'll take seconds. And now we have this. So the problem with JADX, the reason that you don't just use JADX and you never deal with more annoying tools, is that JADX is kind of destructive in a sense. It's pretty much one way. You can use JADX to kind of recover a best estimate of the code, but one, it's not going to compile just like that if you try to recompile it, and two, if you wanted to try to go that route, it would take way longer. What you want to do when you are attempting to patch an APK, you're trying to modify an APK file, is you want to use APK tool. Now, this is non-destructive in the sense that you can go back from the decoded format. You can turn it back into an APK. So, our help usage, this is not the greatest help message. We're going to re-decode that APK. And this time we're going to turn it into not Java source. If you look at the Java files that it gives you, they look similar to the bytecode from the Hermes.js bytecode thing. That'll be in here. But we're interested in replacing this file right here. We're just going to delete that. I'm going to move that in its place, and now we pretty much just want to rebuild that APK. And just like before, actually I have the help right here. Basically the same idea. We just go the opposite direction. And we have to output it to APK tool patched. We'll just call it whatever. This will take a little bit. And now we have an APK. So just like before, if we look at APK patched, we have another zip archive. And there we go. It's a little bit smaller. That shouldn't be a problem. Now, we are going to need to uninstall this version to replace it. You can't just install it over top of it because it's not like an update of this. You'd have to modify more things for that to work. Now we do this and we get an error because if you actually look into the log files and everything, it'll complain that this file is not signed. Now, I actually found I used to do this using a much more complicated process, using jar signer, the kind of proper way you're supposed to sign APKs, but there's actually this tool called Uber APK Signer that will basically sign it in a, okay, now it'll sign it in a kind of debug mode, which is not the kind of thing you want to publish to the Play Store, but it's perfectly fine for stuff like this. Now it'll install, and now it'll start up. And we can try typing in admin. You can type whatever you want in the password. And we get a "you are not the admin" liar, but in the background lies our flag. And that's pretty much how I solved that. Yeah, I could go on about Android trivia, but at this point, I'm probably over time anyways. And I'll just leave that to if anyone has questions.
I'm currently laughing at your background.
That is not, I swear I did not make that up for this.
I'll pretend to believe you.
So, no question quite right away, but I'm really impressed with your methodology and your problem solving skills. It shows that patience and going away, coming back can go a long way in solving a CTF challenge. So I think that I was also just really impressed with how resourceful you were with finding the right tools to accomplish things you wanted to accomplish.
It sounds way simpler than it was. We looked, what did we do?
Oh,
I
yeah.
opened it Android Studio, you opened it, you decompiled it, I opened it in JADX.
Yeah, no.
Yeah.
If you want to get a bit of a better sense for the maze I went through, then actually I should post this in the chat so you guys can see my write-up if you're interested in.
I'm definitely interested in the write-up. Yeah.
I went a bit more. It's kind of a bit beginner focused, so, but I kind of try to explain it from the perspective of not really a CTF player, like as a reader, but as more of a how would you approach this problem in a sense. But yeah, for sure, it is not nearly as straightforward as it may seem when you're actually, in the competition. Yeah, it takes a lot longer than it may seem.
That's a good point. I think that's an important thing to highlight is the fact that what you just showed us is the condensed version after having been through all the the labyrinth that brought you there.
Yeah, exactly.
Yeah.
Even just like going over this presentation, there's like entire sections that I just skip over in this case because they're not interesting and they're not really that informative. But when you're like actually doing it, those are just the rabbit holes you find yourself going down. But yeah, absolutely.
Like when we did the APK challenge that you did there, Taylor, in CyberSci. How long did it take you to find that information?
Oh my
and then
gosh,
how long
yeah.
did it take you to demo that information?
That's a good point. That's a good point. That was a fun one too. Yeah. Awesome. Well, so let's throw some clap emojis in the chat. Thank our presenters here for all their hard work and dedication. And thank you guys for coming out. We'll probably stick around and just chill for a bit if any of you guys want to chat still. But that concludes our CTF hacking demonstration for this week. Next week, we'll just kind of have an open lab on Thursday. And if there's no other questions, if no other comments, then the event is concluded.